Hi, welcome back to Cinderella Math. This is a video for Calc 3 students. This is being filmed in February 2026, so spring semester 2026. This is a study guide for the first test or first exam. This is the part, my third part. My magic pen thing that I write with is just glitching out after about 30 to 40 minutes, so I'm having to do this in parts. But that's okay. So look on the channel under the calculus playlist for parts 1 and 2. It's not in a particular order, so you can watch them in any order, but this is the third video in this series here. And yeah, let's go ahead and get started. Apologies in advance for whenever the pen starts to have issues, but it is what it is. Alrighty. So this particular study guide here, I have already done until number, I think it was 18 or 19 when my pen gave out. Did that one, did that one, did that one. Okay, so I am on number 20. Yes, I'm pretty sure. Pretty sure I did that one. Okay. So if you've been following along with me, if you've watched parts 1 and 2, then this one is resuming at number 20 of the study guide. Yes, the answers are already in there. I've already done this and confirmed that my answers were correct, but now I'm just talking through it, and I will cover those up as we work here together. All right, we are given a vector A, and then we're just going to find the unit vector in that same direction. So we do have a formula here. And again, I'm not actually explaining like the nitty-gritty of what we're doing. I'm just doing the mathematics. So there's other videos that are better than me at explaining this very high-level calculus concepts. I'm just doing the mathematics. So here we go. So we need to know that the unit vector, to find it, you do 1 over the magnitude of the vector multiplied by the vector itself. Okay? So in this case, on ours, we're going to do 1 over the magnitude of A times A itself. All right, so that's going to be 1 over square root. So remember, magnitude or length or distance is the square root of each component squared. So that we're going to have square root of 4 squared plus 2 squared plus negative 2 squared. So, and then we're going to times that by vector A, which is 4, 2, negative 2. This should be vector, sorry. All right, so let's work this out. That's going to be 1 over root. That would be 16 plus 4 plus 4, so that's 24 times our vector. Now, the root of 24, let's break that down. That is root 4 and root 6, so that's 2 root 6. I'm going to come up here. Let me change colors just for room here. That's going to be 1 over 2 root 6 after simplifying the radical and still times the original vector. Distribute through. We're allowed to do that with the scalar multiple. So that'll be 4 over 2 root 6, 2 over 2 root 6, and negative 2 over 2 root 6. And now let's just simplify. This is about to be the final answer here. 4 divided 2 is 2 over root 6. 2 divided 2 would just be 1 over root 6. And this would be negative 1 over root 6. That is the unit vector in the same direction as A. And unit vector, by the way, if you took the magnitude of it, it should be 1. That's kind of what makes something a unit vector. If you think of unit circle that has a radius of 1, a unit vector has a magnitude of 1. So if you really wanted to check this, you could take the magnitude of our answer and it should come out as 1. I'm not going to do that, but you could if you wanted. I would not turn these to decimal approximations. I would leave it exactly like that, the red. And that's what I did there. Let me see if what the key says. Yeah. Oh, okay. They got their roots off the bottom. So what I have there in red is fine, and they did take that. If you're not doing like on computer and you're doing this pencil paper and your professor is going to like grade your work, you might want to go ahead and get the roots off the bottom. So we could times by root 6 times by root 6. So that would be 2 root 6 over 6, which simplifies to root 6 over 3. And then same, we would bounce this off. This is just rationalizing the denominators, right? So that'd be root 6 over 6. Bounce that off, which would be negative root 6 over 6. You don't really need to do that. The red was acceptable, and that's where I left it. But if your teacher or professor or whatever is uptight about no rads on the bottom, then you do need to do that step. But personally, I wouldn't worry about it unless your professor explicitly states that you can't have roots on the bottom. Okay. 21. Find the distance between the planes. Okay, this one's a little complicated. 21. Okay. I did have to kind of look up this formula. And again, I'm not explaining exactly the why behind this. I'm just showing you how to do it. If you want the why, just type that into YouTube, distance between planes, and there's many great videos that'll explain like what we're actually doing. I'm just going to show you the mathematical process. We do want this formula here, that the distance is the absolute value of the vector PQ dotted with the vector n over the magnitude of n. All right, so that's our formula here, the distance between planes. Okay, but you'll see we need a P and a Q. Those are points. So look at this one, this first equation of this plane, and we need to find a point on the plane. The easiest thing to do, since this is equal to -5, would be just look at this. Because those, that would be easy to find the y of, right? So what if we just let x be 0? So that would be -3 times 0. And what if we let z be 0? And then let's solve for y. So this would be 0 minus 5y plus 0 equals -5. So really that's just -5y equals -5, and y is 1. So we just found a point P on that first plane. We plugged in 0 for x, we got 1 for y, and we plugged in 0 for z. So that point is on that plane there. And then let's just do the same thing for the second one. So I'm putting that in the green. And probably the easiest thing to do would be the z this time, because it's even, and so is 26. So what if we still just let x be 0, let's let y be 0, and solve for z. So this would be 0 minus 0 plus 2z is -26. So 2z is -26, and z is -13. So that is going to be our point Q. We did 0 for x, 0 for y, and we got -13 for z. Now, are there other possibilities? Are there other points on those planes? Sure, absolutely. But you want to keep it as easy as you possibly can. All right, I'm going to erase that work now, so if you need that, pause me. Okay, now we're just going to write down our n vector, which is the coefficients that you see. So look how they are the same. -3, same. -5, same. 2, same. That's going to be your n vector. So -3, -5, 2. If you want to get, picky with this, these are parallel planes. And we're finding the distance. So again, watch another video with another teacher that can explain that better, but they are parallel planes. Okay, so now we just need to go into that formula. So we're going to do the dot, or no, sorry, we need the vector PQ, don't we? So you do second x minus first, so 0 minus 0 would be 0. Second y minus first, 0 minus 1 would be -1. And second z minus first, -13 minus 0 would be -13. There we go. Now we can go into the formula. So we're going to do PQ dotted with n and the absolute value of that. So that's going to be 0 times -3 plus -1 times -5 plus -13 times 2, and then we'll take the absolute value. So that's going to be absolute value of 0 plus 5 minus 26, which will be absolute value of -21 which will be 21. There's the top of our fraction. So we're going to have 21 over the magnitude of n, so square root of each component of n squared. So negative 3 squared, negative 5 squared, and 2 squared. So that's going to be 21 over radical, let's see, 9 plus 25 plus 4, 38. And so this distance is 21 over radical 38. And you could probably leave it like that or push that in a calculator, and I think they wanted it rounded twice, and that's 3.41. Okay. So yeah, I left it like that. Let's see what the answer key. I left it like radical. So 3.4, yeah. I would just leave it exact. It's a better, unless it says to round off, leave it exact. It's better. It's more precise. 22. Okay. All right, this one's pretty straightforward here. We are given the vector function in r of t, and we want to find the velocity and acceleration at t equals negative 2. All right, so r of t is the position. The velocity is r prime of t. So let's go ahead and take the derivative. That would be 5, negative 2t, negative 20t cubed. And now that is velocity. That is v of t. But we want the velocity at negative 2. Okay, so that's going to be 5 because there's nothing to plug in. Negative 2 times negative 2. And negative 20 times negative 2 cubed. Work that out. Final answer for the velocity at t equals negative 2 would be 5, 4, and this would be negative 20 times negative 8, so that would be positive 160. There's our first answer. And now they also want the acceleration at that same time. So remember, r double prime of t is your acceleration. So take the derivative of the derivative. So that would be derivative of 5 is 0. Derivative of negative 2t is negative 2. And derivative of the last component would be multiply, so negative 60, subtract 1, so t squared. Okay, so that is the acceleration with respect to t, but they want it at time is negative 2. So this one would stay because there's nothing to plug in. This would stay because there's nothing to plug in. And then this would be negative 60 times negative 2 squared. So that would be negative 60 times 4, which is negative 240. Answer. Yeah, that looks good. That was 22. 23. Complete the parametric equations. Okay. All right, I did have to kind of look up how to do this one too. They kind of started us. They didn't really need to. We can get all of them. So there we go. So we're just given 2 points, x, y, z, x, y, z. And we want to put that into parametric equations, so in terms of t for x, y, and z. All right, so step 1, you want to find, step 1, find v, vector, that passes through the 2 points. So you can kind of let this one be p and this one be q. So we can say we're going to find pq. So again, second x minus first, second y minus first, and second z minus first. So that's going to come out to 7, negative 5, and negative 2. So that's like PQ, or you could call it V. Doesn't really matter what you call it. There you go. Those are going to be the t coefficients. And then just pick either point to be your constants. The video I watched to help me with this said usually we just pick the first one. So these are our constants. So now we're going to have 3 answers. We're going to have x in terms of t, y in terms of t, and z in terms of t. So the way the answer key did it is they put their constant down first. So our constant for x would be -1, and then the t. So that's a positive 7t. And then for y, put your y constant, so the point for y was 2, and then do your z, which we found in that vector, minus 5t. Then put your z constant, which is negative 6, and then your t, negative 2t. Again, I'm not exactly sure what we just did there. I'm sure I could figure it out if I really wanted to, but I got the math, can do the math part. Okay. Alrighty. That is the final answer to 23. Just marking something out on my paper here. Okay. Alrighty. 24. The position of an object at time t is given by the following parametric equations. Find the horizontal velocity, the vertical velocity, and the speed where t equals 2. All right, so if you kind of think of graphing, x is your horizontal axis, and then the velocity is the derivative of the position, right? So here's position, we need the derivative of that. So for our horizontal velocity, do x prime of t, so that would be 6t plus 1, and now do x prime at the time given, which is 2. So that would be 6 times 2 plus 1, 12 plus 1 is 13. So there's our horizontal velocity. And then for vertical velocity, if you think about graphing something, that y-axis is your vertical axis. So our vertical velocity, there's the position of y, take the derivative. So we'll do y prime of t, which would be 6t. And then do it at the time given. So do y prime of 2. 6 times 2 is 12. And there's your vertical velocity. And then speed. Let me see here. Speed is the absolute, or no, it's the, yeah, it's the magnitude of the velocity. Okay, so speed is the magnitude of the velocity. Well, which velocity? Both. It's basically, this is like a vector now, and you do the magnitude of it. So we're going to do square root of 13 square plus 12 square. So that's 169 plus 144, which is 313. Square root 313 is speed. Yeah, you could round that off. It's like 17.69. I would just leave it, and I did. Let's see what they have. Yeah, it's fine. Okay, cool. 25. Find the exact slope to the tangent line of that parametric curve at t equals pi over 6. Okay, we know slope of tangent line from calculus 1 is the derivative. So we're going to go ahead and take both those derivatives. So x prime would be 3 and then times negative sine. This would just look better in front. So x prime is negative 3 sine of t. And then let's do the same for y. Take y prime. So that would be 8. Derivative of sine is cos. There we go. And now, again, kind of just thinking back to previous calc courses, the derivative is often referred to as dy dx, especially in Calc 1. So let's do that. Let's do the derivative of y, dy, or in our case, y prime, over dx, or in my paper, x prime. So I have 8 cosine of t over negative 3 sine t. Now, yes, cosine over sine is cotangent, but I'm just going to leave it. We could turn it to cotangent. I just don't want to. Okay, let's think of unit circle at this particular radian. Pi over 6 is the first one up in quadrant 1. And this point is root 3 over 2, 1/2 CS. All right, so we have 8 times root 3 over 2 over negative 3 times 1/2. Put a 1, so that's 8 root 3 over 2 over negative 3 over 2. But 8 over 2 can slash out and be 4, right? 8 divided 4. excuse me, 8 divided 2 is 4. So this is now just 4 root 3 over negative 3 over 2. We don't divide fractions. We keep, we change, we flip. Our rule from, middle school. So we're keeping the 4 root 3. We're timesing 2 over negative root 3. Sorry, timesing 2 over negative 3. So that would be 8 root 3 over negative 3. Answer. Now the negative we usually put on top, and you can see I typed that there. Or you can put it to the side. We typically don't leave it on the bottom. It wouldn't be wrong, but there you go. They said do not use a decimal. So no need to put that one in the calculator to get a decimal. Okay, 26. All right, find the vector. This is probably the easiest one on the whole thing here. No work to be done. This is where you start, and it looks like you're coming 1, 2, 3 left, so that's why that's negative 3, and then up 2. That's why that's positive 2. The end. Just go from your starting to your ending. And we went left 3, up 2. This is your x difference. This is your y difference. The end. 27. Converting that point to Cartesian. So that is in is that cylindrical or spherical? I think that's cylindrical. Let me look at my notes here. I get them all confused because there's so many formulas. Yes, that's cylindrical. Okay. So we do need some conversion formulas here, but then it's not bad once you have those formulas. So this, if you're allowed a formula sheet, let's write down, and we're going cylindrical to just Cartesian, or like normal, x, y, z. All right, we need to know that x is our cos theta, and y is our sine theta, so very similar to polar, and then z is just z. So there we go. So we are given that this is r, this is theta, this is z. So x is going to be 5 cos 3 pi over 4. Y is going to be 5 sine 3 pi over 4. And z is just going to be 2. The z just stays the same. Let's go to unit circle. 3 pi over 4 is here, the middle one in quadrant 2. So that is left root 2 over 2, up root 2 over 2, CS. Okay, so the x would be 5 negative root 2 over 2. So that would be negative 5 root 2 over 2. That's x. And the y would be 5 positive root 2 over 2. So 5 root 2 over 2, that's y. So our final answer, negative 5 root 2 over 2, regular 5 root 2 over 2, and 2. X, y, z. It does say you could go decimals. I wouldn't, but you could. I don't know why you would want to, but there you go. Great. 28. Find the length of the curve. All right, again, we need a formula for this. So if you're allowed a formula sheet, let's jot this down. A length of the curve given with r, so given in kind of vector form, is the integral of the square root of the x prime squared plus the y prime squared plus the z prime squared, and from a to b. So we are bounded here. They tell us we're going from negative 10 to 7. So ours is going to be the integral from negative 10 to 7 of the square root of, now take the derivative here. I'm going to write this up above, r prime of t. So derivative of cos is negative sine. So this would be negative 2 sine 4t, and then times the derivative of the argument, so times 4. So that's really going to be negative 8 sine of 4t, and then we have to square that. Plus, let's just keep going. Take the derivative of the y piece. Derivative of sine is cosine, so that would be 2 cosine of 4t times the derivative of the argument, derivative of 4t is 4. Chain rule, right? So that's really going to be 8 cosine of 4t, and then we have to square that. Plus, and now let's take the derivative of the z component, which would just be 3. So yay, finally, dt. Okay, let's square those out. This looks worse than it is, I promise. Negative 8 squared is 64. Sine squared is sine squared. You leave the argument. Don't square that. 8 squared is 64. Cos squared is cosine squared. Leave the 4t. Don't mess with it. And 3 squared is 9. Okay. Just looking at the first two pieces. Pull out the 64. That would leave you sine squared of 4t plus cos squared of 4t, and then you still have plus 9. Sine square plus cos square is 1. That is a trig identity, a Pythagorean identity we should know from prior years courses. So this is now 64 times 1 plus 9, which would be 73. Still under the root, still dt. Okay, I'm going to come up in a red pen. So now we have the integral from negative 10 to 7 of root 73 dt. This technically has a t0 with it. So to integrate, this would just be root 73 t1 over 1. No, we don't put the 1s. And then we are going from negative 10 to 7. Always put the top number in first. So this would be root 73 times 7, but it just looks better with this in front. So that's 7 root 73. Always a minus, and then put in the bottom one. So that would be root 73 times negative 10, which would look better in front. So that'd be negative 10 root 73. Minus minus turns to plus. 7 plus 10 is 17 root 73. That is the length of this curve from negative 10 to 7. If you put that in the calculator and round it off, it's approximately 145.25, but I wouldn't. I would just leave it in exact form. And yes. Yeah. Now, actually, I didn't really need to do any of that work. Since we were allowed a calculator, I could have just done integral int from negative 10 to 7, parentheses, square root, and then you still would need to take the derivatives yourself. So my derivatives, the x prime was negative 8 sine of 4x, because Desmos doesn't know t, and then that squared. Make sure you go out of that inner parenthesis. And then it was plus the next derivative, the y prime, if you will, was 8 cosine of 4x, because again, Desmos doesn't want t. Go out of both of those parentheses, squared, plus 3 squared. Go out of everything, dx. Ooh, did I not type something right? Right here should be negative 10. That's what it is. There we go. And now it says it doesn't like it. What's wrong? Oh, it looks like I have a decimal. There we go. There we go. 145. You could just, if you wanted to, just copy and paste that whole thing. Or it says give answer to 2 decimals. So I guess that'd be 145.25. Let's see if they take that. I'm assuming they will. Yeah. But I still like the, the one I had. 17 square root 73. I still like that one. It's more exact. Yep. Okay. But you don't have to work it out, really. You could just let Desmos do it. Okay. Here we go. 29. Find the unit tangent vector at t equals 0. So we do have another formula here. The unit tangent vector is denoted as capital T of t. And the formula here is r prime of t over the magnitude of r prime of t. Or you could do 1 over the magnitude of the derivative times r prime. So it's very much like the unit vector that we had a few questions ago, similar, because it is the tangent unit vector. Okay, so obviously we need to get r prime. Let's do that. Let's take the derivative of our given. First component, it's all that. The derivative would be negative 20t to the fourth, and then the derivative of negative 3 would just be nothing. Second component would be negative 3e to the t times 1, because technically we're supposed to times the derivative of the power, but times 1 is not going to make a difference. And then finally, derivative of sine is cosine, so this will be 2 cosine of 3t times the derivative of the argument, which is 3. 2 times 3 will make 6, so I'm just going to erase that and make that 6 cos of 3t. Okay, there's our prime. All right, but now, I think I covered up, it did say that we want this at t equals 0. So let's now evaluate r prime at 0. So everywhere you see t, give it a 0. So this would be negative 20, 0 to the fourth, negative 3 e to the 0, and 6 cosine of 3 times 0, which is 0. So this will just be 0, negative 3 times 1, because anything to the 0 power is 1, and 6 times 1. Cosine of 0 is 1. You can get that off unit circle. So this is 0, negative 3, 6. Okay, that is our prime that we want there. And now let's go into the formula. You can do either. I'm going to go to the bottom one, but again, it doesn't matter. So I'm going to do 1 over the magnitude of what we just found. So that would be 0 squared plus negative 3 squared plus 6 squared times what we found. So 0, negative 3, 6. Okay, let's get that magnitude on the bottom. So that would be root of 0 plus 9 plus 36. So that's root 45. So we have 1 over 45. Let me bring that to the side. You can simplify that because that's 9 and 5. So root 9 is 3. So that's going to be 1 over 3 root 5, simplifying the radical, times 0, negative 3, 6. Distribute through a scalar, as we have done in the past. I'm going to come up to the top in a pink pen. So anything times 0 is still going to give us 0. This second one would be negative 3 over 3 root 5. And the last one would be 6 over 3 root 5. Let's simplify. So 0, this would cancel and be negative 1 over root 5. And this would reduce to 2 over root 5. That is our tangent vector, unit tangent vector. Again, you could get those roots off the bottom. I wouldn't. This program took it with the root on the bottom. Unless you're doing this by hand and the teacher says you must clear the bottom of radicals, fine. But otherwise, leave it. So this pink answer. Yeah, don't do that. No, don't. Okay. And finally, number 30, a vector with magnitude 7 in a direction of 145. Write the vector in component form. So we kind of want to think about what that looks like. Here's 0 degrees. Here's 90. Here's 180. So 145 is, something like that. That might be a little too big, but that's okay. You get my point. And magnitude 7 means this length of the vector is 7. Okay? Let me actually put that 7 on the other side. Okay, we're going to make a triangle. Drop straight down over right angle theta. And then this is SOHCAHTOA, right? But we don't know theta. Well, yeah, we do. If this is 45, remember from high school geometry, a straight line is 180. So just do 180 minus 145. And this angle is 35 degrees. This would be up y, and this would be over x. So SOHCAHTOA from high school, good old SOHCAHTOA. Let's see here. this would be the opposite, and then that's the hypotenuse. So sine of 35 is y over 7. So times by 7, so 7 sine of 35 is your y. And then put that into the calculator, make sure you are in degrees. So I'm going to go over to the wrench, turn it to degrees. 7 sine 35. So 4.02, rounded to 2 places. There we go. Right. Let me there we go. There's our y, 4.02, and you can see right there, there's the y. And now let's do something similar for the x. The x here is adjacent, and then we still have the hypotenuse, so cosine of 35. Adjacent is x, hypotenuse is 7, times by 7. So 7 cosine of 35 is x, and again, just make sure whatever calculator you're using is on degrees. I'm typing in 7 cosine of 35, 5.73 rounded, but it does need to be negative because we went left. So x is negative 5.73. So that's why it is worth it to draw the picture and see that you're in quadrant 2, so it's left and up. So we knew this one was going to be negative and this one would be positive. So that's really a SOHCAHTOA question in disguise. And that's it. I wonder if they would have taken, just for kicks and giggles, the x was actually 7 cosine of 35 degrees, and the y was 7 sine of 35. I wonder if they would have taken that. Let's see. No. Okay. So they did want it rounded. And they do want it in vector, so write the vector in component form. So make sure you do the symbols. There we go. Okay. All right, that concludes it. Yay. Sorry that this was broken into the 3 parts, but honestly that might be good because then you can kind of study in chunks. Anyway, I hope that was helpful, and I hope to see you again soon. Bye-bye.